Have you ever considered the possibility that the very rain that nurtures life could also bring about destruction? Picture this: rain, a symbol of life and rebirth, cascading down from the heavens, nurturing the earth below. It's a sight we're all familiar with, and one we usually welcome. But what if I told you that sometimes this life-giving rain can turn into a silent, unseen threat? This is the reality of acid rain, an environmental issue that's been casting a shadow over our planet for decades. Acid rain, as the name suggests, is rain that's become acidic due to atmospheric pollution. It's not just rain though. Snow, fog, dew, and even dust can become acidic. This is a global problem, not confined to one geographical location or climate. Everywhere there are factories, power plants, and cars, there is the potential for acid rain. So where does acid rain come from? It all starts with the burning of fossil fuels. When we burn coal, oil, or gas, we release sulfur dioxide and nitrogen oxides into the air. These gases are carried high into the atmosphere, where they mix with water, oxygen, and other chemicals to form acidic compounds. These then fall back to Earth as acid rain. But why should we care about a bit of extra acidity in our rain? Well, when acid rain falls on soil, lakes, and rivers, it can change their chemistry, harming plants and wildlife. It can corrode buildings, bridges, and statues. It can even affect our health, causing respiratory problems and other illnesses. So what turns the life-giving rain into a life-threatening acid rain? It's a complex process involving a cocktail of pollutants, atmospheric conditions, and chemical reactions. But at its heart, it's a human-made problem, a consequence of our reliance on fossil fuels. Let's dive into the science. The story of acid rain begins high above our heads, in the clouds. A drop of rain, in its purest form, is a marvel of nature's design. It starts as a simple molecule of water that evaporates from the Earth's surface, rising high into the sky. As it ascends, the water vapor cools and condenses, forming delicate clouds that grace our horizons. But this is just the beginning of the journey. As these water droplets move through the atmosphere, they encounter a cocktail of gases. Among these are two particularly harmful pollutants, sulfur dioxide and nitrogen oxides. These gases are primarily released by human activities, such as burning fossil fuels in power plants, cars, and factories. When sulfur dioxide and nitrogen oxides meet water, they undergo a series of chemical reactions. Sulfur dioxide reacts with water to form sulfurous acid, which then further oxidizes to become sulfuric acid. Meanwhile, nitrogen oxides react with water to form nitric acid. Now, these aren't the friendly acids you might find in a citrus fruit or a cup of coffee. These are strong, corrosive acids, the kind that can eat through metal and stone. And they're floating around in our clouds, mingling with our raindrops. What was once pure, clean water is now transformed. It has become acid rain. This rain, laden with harmful acids, eventually falls back to the earth. It's in the raindrops that pelt your windows during a storm, in the mist that blankets your morning fields, and even in the snowflakes that fall on a winter's day. Acid rain is more than just a drop of water. It's a drop of water that's been on a journey that's taken it through the fires of human industry and into the heart of our atmosphere's chemistry. It's a journey that transforms it from a simple symbol of life and growth into a harbinger of damage and decay. With this understanding, we can see the path from clouds to consequences, from the sky above to the ground below. Acid rain is not a localized problem, but a global one. This statement may seem daunting, but let's unravel it together. Acid rain is a worldwide issue because the pollutants that cause it know no boundaries. They are carried by wind and weather patterns, often from one country to another, across continents, and even oceans. Take, for instance, industrialized countries like China or the United States. Their factories and power plants emit tons of sulfur dioxide and nitrogen oxides into the atmosphere. These pollutants can then be swept thousands of miles away by the wind. Imagine the smoke billowing from a factory in Beijing could end up causing acid rain in Seoul. Similarly, sulfur dioxide emissions from power plants in the United States can be carried by the wind across the Atlantic, contributing to acid rain in Europe. This is not just a hypothesis, but a reality that has been confirmed by numerous scientific studies. But the impact of acid rain is not limited to the places where the pollutants land. The effects are felt downstream, in rivers and oceans that become more acidic, harming aquatic life. And it doesn't stop there. Acid rain can also affect soil chemistry, changing the very foundation of our ecosystems. Now, let's take a moment to consider the countries that are most affected by acid rain. These are often developing countries with less stringent environmental regulations and a heavy reliance on coal for energy. They bear the brunt of the consequences, from damaged crops and forests to polluted water sources. Yet, the pollutants causing this damage may not even originate from their own industries. So you see, acid rain is truly a global issue. It's a reminder of how interconnected our world is and how our actions can have far-reaching impacts. It's a call to action, urging us to rethink our energy sources, our industrial processes, and our commitment to protecting our planet. Indeed, the rain that falls in your backyard might be carrying the consequences of pollution from thousands of miles away. Acid rain doesn't just fall on cities and towns, but also on forests, lakes, and rivers. When this corrosive precipitation descends upon our natural environments, the effects can be truly devastating. Let's start with plant life. Acid rain can strip essential nutrients from the soil, leaving trees and plants struggling to survive. Over time, these life-giving forests can become barren landscapes, their once vibrant greenery replaced by lifeless skeletal remains. But the impact doesn't stop there. This nutrient depletion seeps into our water systems, affecting lakes and rivers. Aquatic ecosystems are particularly vulnerable, as acid rain increases the acidity of the water, making it inhospitable for many forms of life. Imagine a lake, once teeming with a variety of fish, now reduced to a silent, lifeless body of water. And then there are the animal populations. Creatures that rely on plants for their diet can find their food sources dwindling. The situation is even more dire for those that live within the water. Fish, frogs, and other aquatic species can struggle to survive in the acidified waters, leading to a significant drop in their numbers. The ripple effect of this can be felt throughout the food chain. Predators that rely on these creatures for sustenance may find their food sources disappearing, leading to a decline in their own populations. And so the cycle continues, each link in the chain weakened by the insidious effects of acid rain. And it's not just the individual species that suffer. The loss of a single species can disrupt the delicate balance of an entire ecosystem. Imagine a complex interwoven tapestry where each thread represents a different species. Now imagine what happens when you start removing threads. The entire tapestry begins to unravel, its intricate patterns and structures lost. The damage caused by acid rain is not just aesthetic, but can lead to a loss of biodiversity and the disruption of entire ecosystems. The impact is far-reaching, altering the very fabric of our natural world. It's a grim picture, but one that we need to confront if we're to understand the true cost of acid rain. If you think acid rain only affects nature, think again. It's a common misconception, but the truth is, acid rain's impact extends far beyond our forests and water bodies. It has profound effects on both our health and the infrastructure that keeps our society functional. Let's start with the health impacts. Acid rain can exacerbate respiratory conditions such as asthma and bronchitis. When the pollutants that cause acid rain, sulfur dioxide and nitrogen oxides, are in the air, they can be inhaled. These particles penetrate deep into sensitive parts of the lungs, causing inflammation and worsening respiratory diseases. For those with no existing conditions, long-term exposure can increase the risk of developing such ailments. Now think about our children, the most vulnerable members of our society. They play outdoors, often in areas where these pollutants are at their highest concentration. They breathe faster, inhaling more air and, consequently, more pollutants. This exposure at a tender age can lead to serious health problems later in life. Moving on to infrastructure, acid rain is a silent destroyer. The acidity can corrode metals, weaken structures, and damage buildings and monuments. It's not just a matter of aesthetics or preserving our cultural heritage. The economic costs of repairs and replacements are enormous. Take, for instance, a city's water supply system. Acid rain can corrode the pipes, leading to leaks and contamination of the water supply. This not only poses a health risk but also results in significant repair costs. Similarly, our roadways, bridges, and other structures are not immune to the corrosive effects of acid rain. The societal costs are harder to quantify but just as significant. Imagine the disruption to daily life if a bridge collapses or a road is closed for repairs. The ripple effects on commerce, transportation, and overall quality of life are substantial. So the next time you see rain falling from the sky, remember, it's not just water. It's a complex environmental issue with far-reaching impacts. As we can see, acid rain leaves no aspect of our lives untouched. What does the future hold for acid rain? This question gives us pause as we consider the many factors that could sway the balance of our environment. One of the most significant factors is climate change. As global temperatures rise, we could see an increase in the frequency and intensity of rainfall. More rain could mean more opportunities for acid rain to form, especially in areas with high levels of air pollution. Industrialization is another crucial factor to consider. As more countries develop industrially, the levels of sulfur dioxide and nitrogen oxides in the atmosphere could increase, leading to more acid rain. However, technological advancements could potentially mitigate this. For instance, more efficient machinery could reduce emissions, while advanced filtration systems could help to remove harmful substances from the air before they have a chance to contribute to acid rain. International cooperation is also key. Acid rain is a global problem and it requires a global solution. Countries need to work together to implement policies and practices that will reduce the harmful emissions that lead to acid rain. This might include setting stricter emission standards, investing in renewable energy sources, and encouraging industries to adopt greener practices. There are also promising developments in the field of geoengineering, where scientists are exploring ways to directly counteract the effects of acid rain. This could involve anything from cloud seeding to alter rainfall patterns, to the development of materials that can neutralize acidic precipitation. However, it's important to remember that these solutions are not without their own challenges and controversies. They require careful planning, significant investment, and the global will to act for the benefit of our environment. So, what does the future hold for acid rain? The answer is complex and uncertain, shaped by a myriad of factors from climate change to industrialization and international cooperation. But there is one thing that is clear. The future of acid rain is in our hands. The choices we make today will determine the world we live in tomorrow. We are not helpless in the face of acid rain. Indeed, it's quite the opposite. There are various strategies and solutions we can employ to combat this environmental adversary. One of the most effective methods is transitioning to clean energy. By reducing our reliance on fossil fuels, we can significantly decrease the amount of sulfur dioxide and nitrogen oxide released into the atmosphere, the main culprits behind acid rain. Solar panels, wind turbines, hydroelectric power, and nuclear energy are all viable alternatives that produce negligible amounts of these harmful gases. In addition to clean energy, implementing pollution controls on industrial facilities can also curb the production of acid rain. Technologies such as flue gas desulfurization, also known as scrubbers, can remove up to 90% of sulfur dioxide emissions from smokestacks. Similarly, catalytic converters in vehicles can reduce nitrogen oxide emissions, another significant contributor to acid rain. However, these technological solutions need to be complemented by strong policies. Governments worldwide can play a pivotal role by imposing stricter regulations on emissions, incentivizing the use of clean energy, and promoting research into new eco-friendly technologies. International cooperation is also crucial, as acid rain knows no borders. Through treaties and agreements, countries can work together to tackle this global issue. On a more personal level, each of us can contribute to the fight against acid rain. Simple actions like conserving energy, recycling, and using public transportation can make a big difference. By educating ourselves and others about the harmful effects of acid rain and the steps we can take to prevent it, we can foster a more environmentally conscious society. In the end, it's not just about combating acid rain. It's about safeguarding our planet for future generations. It's about ensuring that the air we breathe, the water we drink, and the soil that nourishes our food are clean and healthy. In the fight against acid rain, everyone has a role to play. From individuals to governments, we all have a part in protecting our planet. So we've traced the path of acid rain from clouds to consequences. We started this journey together, delving into the unseen threat that is acid rain. We've uncovered how this invisible menace is created, learning about the harmful substances released into the air that mix with water vapor to form acid rain. It is a process that begins high up in the sky, far removed from our daily lives, yet its repercussions are felt globally. We've seen how acid rain doesn't discriminate, reaching every corner of our world. It's not just a local problem, but a global one that affects us all. From the lush forests of the Amazon to the bustling cities of Europe, no place is immune to its destructive touch. We've also explored the devastating impact acid rain has on nature. It's not just about the rain, but the acid deposition that affects our soils and water bodies, wreaking havoc on our ecosystems. It's a silent killer, slowly but surely damaging our precious biodiversity. But acid rain doesn't stop at nature. We've seen how it affects us, humans, and our infrastructure. It corrodes our buildings, deteriorates our monuments, and threatens our health. The impact is far-reaching, touching every aspect of our lives. Looking into the future, we've considered the potential consequences if we continue on this path. But we've also seen that it's not all doom and gloom. We've learned about the proactive steps being taken to fight against acid rain, from legislation to technological advancements. In wrapping up, it's clear that understanding and addressing the issue of acid rain is of paramount importance. It's not just about preserving the world for future generations, but ensuring the health and well-being of our planet and its inhabitants right now. Remember, the rain that falls from the sky is a reflection of the world we've created. Let's make it a world worth living in.